how to do the graphical portion and how to get your information for the mathematical portion. Okay, fake data is on the board. Now, if you noticed on the compass, which way did the compass go? This was 0 up here at north, right?
Mm-hmm.
And which way did the degrees go?
East.
They went clockwise, right?
Oh, yes.
Which way have we been reading when we're in class and we're reading it?
Counterclockwise.
The other way. All right, so this is fake data that would be based off of a compass. I am going to use a scale of 2 inches is equal to 1 meter. I think most of you guys are going to be using something like 1 centimeter equals a meter or something on your papers. Okay? All right, so now going with the idea, what you're going to need to do on your page when you're doing your work, first off, you need to identify where your north, south, east, and west are. I don't care where you do it. It could be facing this way or something. It doesn't matter. If you're going down, that's your north. It doesn't matter. You have to have that, though. That says which way is it going. Okay, so that means if this is north, the way our compass read it was we start here at 0 degrees, and what this would be reading would be 323 degrees. So if I put this, if I center my protractor, right, that means this is 180. Somebody have a calculator? Give me a quick 360 minus 323.
360 minus what?
Or 323 minus 180.
Well,
I'm messing you up, I know. 323 minus 180.
143.
Okay. So there's 180. And 180 plus 143, you said, is 323. So I'm going to come up here, and I'm going to, so that was 180 going this way. Now the other 143. What I'm doing is I'm just putting a dot where that 323 is. Okay? So now, anything that I do on this line, from here out, anything I do on that is going to be at 323 degrees. Okay? Now my scale is 2 inches is equal to 1 meter. So that means I want to draw 2 times 8.
8 inches.
2 times 8, so it's 16. All right, I'm going to draw 16 inches. And I'm going to set it up so that it is on that dot line that I just had. Okay. Maybe I should have done a smaller scale, we'll find out. Okay. So that means that this vector right here is a scale of 8 meters at 323 degrees. I think I am going to go back. I'm going to erase this, guys. I'm going to make it 1 meter. 1 inch equals 1 meter, because that's kind of long. So give me a second. I don't like that.
erase.
Yeah, erase.
Oh, I meant the video.
Move my dot there so I can see my line.
Hello, guys.
Okay, so it's 8.
Hello.
Right about there, actually. Okay. So here is 8 meters at 323 degrees. So the next thing I'd want to do is 6.5, right? Okay, so if I want to do that, I'm going to try and do these tip to tail. So if this is my tip, give myself a small, just so I can see what's going on, axis. You guys will be able to use the grid marks on your paper pretty well. All right, so this is 270 degrees. Again, if this is north, I'm going to go around this way. And I'm going to use a small protractor now because it's a small thing.
It's 97 degrees.
97 is what it is? Okay. All right, so I would go 180, and then 180 plus 97. Here we go. Too messy. Too messy. Okay. Right there. All right, and so it's 6.5. So I want to use 6.5 inches. I'm going to measure that.
Attention teachers and staff and students. Please don't forget to support our team by tuning in to Masterminds on Sunday, November 5th at 11 a.m. on Channel 5. Again, please don't forget to support our team by tuning in to Masterminds on Sunday, November 5th at 11 a.m. on Channel 5. Thank you. Have a great weekend.
340 points to 60 points.
I saw that on Twitter.
Woo. All right, so now I just do that again. I'm going to do that every single time until I get to the end.
What if we got directions?
Huh? The north, south, east, west?
Yeah, like 173 degrees southeast.
Way 173. Well, think about that. 0, 180, 173 southeast. You can ignore the letter parts from this one because we're just going off the 360 degrees.
We're just using that, not
yeah, just the degrees. Because we don't need to use north, south, east, or west because we're using the full circle of 360.
When we do the chart,
right?
Thing, right?
So, like, basically, what happens here is this is basically my compass reading,
yes.
And this is what I'm going to end up using to get the graphicals. Like, if all I had was 2 vectors, my resultant would be like this. Here's 1. Okay. All right, and that is, since that resultant is 30.55, so measuring that, it would actually be 30.55 here at whatever that angle is, okay? That would be my resultant graphically. Now, when we've been using it for the mathematically, doing the x, y, magnitude, and theta, we haven't been using numbers like this, right? Okay, we've only been using up to 0 and 9. So if you don't want to mess with doing that, what you can do is go, all right, well, let's finish this part, okay? 360 minus 323. What is that, 67? That is 67 degrees west of north. And now, based off of this, I just kind of turned that 8 meters at 323. I turned that into the type of number that we've been using over here. So I could write that over here. It's still 8 meters.
Is that 37?
30, it's, this is 323.
360, 323?
360 minus 323.
Yeah, 360 minus 323 is 37.
Oh, I can't add, okay. 330, what was that?
37.
37, okay. So that'd be 8 meters at west 37 north. And then I can just go ahead and finish filling in the rest of this grid the way we've been doing in class. Okay, so is that enough to get you guys going for the rest of the lab for the graphical
I think
portion?
So.
All right.
Is due Monday?
It's not due Monday. We're going to have class time to work on it on Monday, and I'll give you a due date later. I just wanted to get the video done because people are going to want to see it, and I don't want to have to keep repeating myself. All right, thank you. Thumbs up. Yeah, have a good weekend, everybody.